Good morning, everyone. Today we are reviewing our Chapter 11. We are reviewing so we are ready for our test tomorrow. The first one we're going to do is just simplifying radical expressions. So this first box on the right I left blank in case we need to add any other notes besides what we do on here. But the first one we're going to do is simplify 3 times the square root of 12 times x to the 7th power. So when we're simplifying these radicals, we need to see if we have some factors. So I see that I have 12. The factors of 12 I know are 3 and 4. Now 4 I can simplify again, so 2 and 2. Now what I see is I have a pair, so I'm going to circle that and I'm going to write my pair down here. Now we still have that 3 from the front, so I'm going to have 3 times 2. This square root of 3 I can't do anything with, so I'm going to leave that for now. Then x to the 7th, I have 1, 2, 3, 4, 5, 6, 7 x's. So how many x's I have? Well, I have 1, 2, 3 pairs, so I have x, x, and x here. What I don't, I just have one single x that I can't do anything with, so that's the square root of x. So what I don't have, or what I have that I can't do anything with is a 3 and an x. So if I multiply this all out then, 3 times 2 is 6. Then I have 3 x's, so x cubed times the square root of 3x. That is my answer. That cannot go any simpler than that. Now if we go to the next one, the first one I see is 3 times the square root of 3, and I can't do anything to the square root of 3, because that's a prime number. So I go to the next term, and it says a negative 6 times the square root of 27. Now the square root of 27 I can factor. I can factor that to 9 and 3. 9 I can factor to 3 and 3. I see a pair of 3's. So what I'm going to have then is 3 times the square root of 3 minus, I have that pair of 3's, so I'll put that 3 there, times the square root of 3. Now we can't forget the 6 that we have, so I'm going to multiply that by 6. So I have 3 times the square root of 3 minus 6 times 3, which is 18, times the square root of 3. Now because I have 2 square roots of 3, that's basically saying that we have like terms. So we can combine everything else. So I have 3 minus 18. That's going to give me a negative 15. And then our like terms is that square root of 3. That's just like saying we have an x at the back. So the simplified version is negative 15 times the square root of 3. Alright, the next one says we have 2 times the square root of 3 plus 5 squared. When we have that squared, we basically have 2 times the square root of 3 plus 5 twice. So 2 times the square root of 3 plus 5 times 2 times the square root of 3 plus 5. So I have 1, 2, 3, 4 terms, so I'm going to draw a 2 by 2 box. 2 times the square root of 3 plus 5, 2 times the square root of 3 plus 5. So if I multiply these out, 2 times 2 is 4. The square root of 3 times the square root of 3 is the square root of 9. 2 times 5 is 10. And then I don't have any square roots, so I'm going to say the square root of 3. Keep that the same. Same thing down here. I'm going to have 10 times the square root of 3 and then 5 times 5, that's 25. So if we write that out, what we have is 4 times the square root of 9 plus 10 times the square root of 3 plus 10 times the square root of 3 plus 25. I see two like terms. These two have the square root of 3. So I'm going to combine those two. But first I'm going to simplify the square root of 9 to 3 and 3. So basically now I'm going to have 4 times 3 plus 20 times the square root of 3, because 10 plus 10 is 20, plus 25. 4 times 3 is 12, plus 20 times the square root of 3, plus 25. Now again, I see two more like terms. I see 12 and 25. So 12 plus 25, that's going to give me 37 plus 20 times the square root of 3. Next, we need to solve these equations. So we're not simplifying anymore, we're solving. So first thing we got to do is we got to get rid of our addition and subtraction, because we do PEMDAS, but we do it backwards to solve these. So my addition or subtraction, well, I'm going to subtract 7 because that's the opposite of plus 7. So we get the square root of 2x equals 5 minus 7. That gives me a negative 2. Now right away, I see that my answer is negative. So I know that this is going to be no. Oh, let me write this a little bit better here. I know this is going to be no solution, because I can never have a square root and a negative number at the same time. Now, it does say to check, so we could check this to see if we are correct. So we'll have the square root of 2x equals negative 2. Now to get rid of that square root, I'm going to have to square everything. So that's going to cancel out. We get 2x equals negative 2 squared. Well, that's 4. If I divide by 2, I get x equals 2. So now I would put that x equals 2 back into the original equation. So it's the square root of 2. Now instead of x, we have 2, so times 2, plus 7 equals 5. 2 times 2 is the square root of 4, plus 7 equals 5. Square root of 4 is 2, plus 7 equals 5. 2 plus 7 is 9. 9 does not equal 5. So we know that this no solution is correct. Here we have a square root on both sides, so we're going to get rid of that by squaring both sides. When we square both sides, the square root and the squares cancel out, so we have 2x plus 10 equals x plus 7. Now I'm going to subtract x to move that over. So I'm just left with x plus 10 equals 7. Here I'm going to subtract 10. And we get x equals a negative 3. If we were to check this, we would have 2 times negative 3 plus 10 equals square root of negative 3 plus 7. 2 times negative 3 is negative 6, plus 10 is 4. Negative 3 plus 7 is 4, so we would have the square root of 4 equals the square root of 4, which would make this solution true. X equals negative 3. Alright, next one. I left this space open intentionally because this problem might get a little bit longer. I see a square root. We need to get rid of that square root by squaring. When we square one side, we have to square the other. So 2 squared, we're going to have 4. X squared is going to be x squared. The square root and the square cancel out. We get 11x plus 3. Now I want to solve, so I want a 0 on one side. So what I'm going to do is move everything else over. So I'm going to subtract 11x and subtract 3. So we get 4x cubed, or squared, minus 11x minus 3 equals 0. Now what I have is a trinomial. So the trinomial tells me that I have to factor this. So I'm going to draw my box here. 4 times a negative 3 is going to give me a negative 12x squared. Then I'll have negative 11x down here. The two numbers that add up to negative 11 and multiply to negative 12 are negative 12x and 1x. So now that I have those two numbers, I can come up with my box here. My A is 4x squared. My C is negative 3. Then I have negative 12x and 1x. So I see that one of them is 1, the other one is 12. That means I'm probably going to have my 4 here and just have a 1 here. So 1x and 4x. 4 times negative 3 is going to give me negative 12x. 1 times 1 is going to give me 1x. And then negative 3 times 1 gives me negative 3. So then what we're left with is x minus 3 and 4x minus 1 equals 0. So if we solve this, then we'd have x minus 3 equals 0 and 4x minus 1 equals 0. So I'm going to add 3. We get x equals 3. Here I'm going to add 1 and get 4x equals 1. Divide by 4, and x equals 1/4. So now I would check these to see if they are extraneous. If I put x equals 3 in, I would have 2 times 3, which is 6. Then 11 times 3, which is 33, plus 3 gives me the square root of 36. Square root of 36 is 6, so x equals 3 works. Now if I put in a fourth, we get 2 times sorry, this should be a plus 1, and this should be a negative 4. 2 times negative 1/4 gives me negative 1/2. I can't get a negative number, so that is my extra solution. Negative 1/4 is my extra solution, or extraneous solution. Alright, next one we need to find these unknown lengths. So this is one of those long ones. So what we're going to have then is x plus 1, oh, not 2, x plus 1 squared plus x plus 3 squared equals 2 times the square root of 5 squared. When we solve these, we're going to have to draw a couple boxes. We'll have x plus 1 and x plus 1. X times x is x squared. X times 1 is 1x. X times 1 is 1x. 1 times 1 is 1. So we have x squared. Now I'm going to combine my x's. So 1x plus 1x gives me 2x plus 1. Here we're going to have x plus 3 times x plus 3. X times x is x squared. X times 3 is 3x. 3x and 9. If I combine my two 3x's, what I'm left with is x squared plus 6x plus 9 equals 2 squared is 4, square root of 5 is 5, so that gives me 20. Now I see that I have a like term here, x squareds. So 2x squareds, well, that gives me 2x squared. Then I have 2x and 6x, that gives me 8x. Then 1 and 9, that gives me 10, equals 20. I'm going to move the 20 over. So 2x squared plus 8x minus 10 equals 0. So now I have a trinomial. I am going to factor that out. I can take 2 out of all of those. So I'm going to take that 2 out, and I get x squared plus 4x minus 5 equals 0. So I'm going to factor x squared plus 4x equals 5. I get negative 5x squared, 4x, negative 1x, and 5x will add up to 4 and multiply to negative 5. If I square this here, or I mean factor this, I'll have x squared, negative 5, 5x, and negative 1x. X and x, this has to be a 5. This has to be a negative 1. So we're left with x minus 1 equals 0, and x plus 5 equals 0. I'm going to add 1 and subtract 5. Now here I get a negative number, so I know that that's my extra solution. X equals 1 is going to be my answer. Next one, use the distance formula and the converse to determine whether the points are vertices of a right triangle. Now the distance formula, remember, I'm going to go back to my first slide. I'm going to write the distance formula in here. Is the square root of x2 minus x1 squared plus y2 minus y1 squared. So then if I go back to this problem, first thing I'm going to start with is these first 2 points. So I get the square root of 0 minus a negative 5 squared plus negative 4 minus a negative 2 squared. Square root of 0 plus 5, well, that gives me 5 squared. Negative 4 plus 2, that's going to give me a negative 2 squared. So I get 10, or no, not 10, 25 plus 4, which is the square root of 29. So I'm going to leave it like that for now. The next one, we have 0, negative 4, and 2, negative 2, 3. So we have the square root of negative 2 minus 0 squared plus 3 minus a negative 4 squared. So I get the square root of negative 2 squared plus 7 squared. We get 4 plus 49, square root of 53. Now I'm going to circle that and leave that for now. So then we finally get our last one, which is negative 5, negative 2, and negative 2, 3. So we'll have negative 2 minus a negative 5 squared plus 3 minus a negative 2 squared. Negative 2 minus a negative 5, well, that's negative 2 plus 5, which is 3 squared, plus 5 squared, so 9 plus 25 gives us the square root of 34. Now if I put this into my Pythagorean theorem, the highest one I have is the square root of 53, so that's my C. Then I have the square root of 29 plus the square root of 34. I have those all squared. So if I square them, they cancel out, and I get 29 plus 34 equals 53. 29 plus 34 gives us 63 equals 53. Well, that's not true. 63 doesn't equal 53, so this is not a right triangle. Alright, we're almost done. The time t in seconds for a pendulum to complete one swing can be found using the equation 2 equals 2 pi, or t equals 2 pi times the square root of L divided by 32, where L is the length in feet. Find the exact time it takes for a 4-foot pendulum of a grandfather clock to complete one swing. So what we'll have then is t equals 2 times, now I'm going to use 3.14 for pi, times the square root of 4 divided by 32. So 4 divided by 32, that's going to give me 1 over 4, or 1 over 8, sorry. So then I'll have 2 times 3.14, which is 6.28, times the square root of 1/8. So now that's something I'm just going to put into my calculator, because then it makes it easier. So I get t equals 2.2. Last one, find the midpoint of the line segment with the given point. So I'm going to add one more thing. The midpoint that is x1 plus x2 divided by 2, and y2, or y1 I should say, plus y2 divided by 2. That's going to give me the midpoint. So I'll go to my last problem. x1 plus x2 is 9 plus 3 divided by 2. And then we have negative 2 plus a negative 2 divided by 2. 9 plus 3 is 12 divided by 2. Negative 2 plus negative 2 is negative 4 divided by 2. 12 divided by 2 is 6. Negative 4 divided by 2 is negative 2. So my